Okay, let's go. Number 1. Neutron star Chila. In 1980, physicist Robert Forward published a novel called Dragon's Egg. Forward held a PhD in gravitational physics from the University of Maryland and worked at Hughes Research Laboratories, where he published peer-reviewed papers on antimatter propulsion, laser sail physics, and gravitational wave detection concepts that preceded the instruments that eventually made those detections possible. He was not primarily a novelist. The book was a thought experiment in physics. The question it asked was this: can anything live on a neutron star? The surface of a neutron star is approximately 12 miles in diameter. Surface gravity is 200 billion times Earth's. The magnetic field exceeds 10 to the power of 12 Gauss. The surface material nuclear pasta is matter compressed so densely it no longer behaves as individual nuclei, but flows as continuous nuclear fluid. In 2018, observations of neutron star crust oscillations published in Nature Astronomy confirmed the nuclear pasta layer's existence. It is not speculative, it is observed. Nuclear chemistry operates approximately 10 million times faster than atomic chemistry. The strong nuclear force mediates interactions at far higher energies and shorter ranges than electron shell chemistry. A nuclear chemistry metabolic process that accomplishes the equivalent of a cellular cycle does so at 10 million times the rate of the biological equivalent. The implication Forward worked through is specific. An organism with nuclear metabolism experiences time at 10 million times the rate of a chemistry-based organism. 1 year of human clock time is 10 million years of experienced time to such an entity. Earth biology has existed for approximately 3.8 billion years. A nuclear organism on a neutron star that has been in existence for the same span of external clock time would have experienced 38 trillion years of subjective duration, not 38 trillion years of passive waiting. 38 trillion years of evolution, learning, civilization, and whatever comes after. Forward's Chila, the creatures in Dragon's Egg, are 0.5 millimeter in diameter and live on the neutron star's surface. They evolve, develop tools, develop language, develop science. Carl Sagan called Dragon's Egg the most technically accurate science fiction novel he had read. Forward's physics was not fantasy. It was a direct extrapolation from the confirmed properties of neutron stars. There are approximately 1 billion neutron stars in the Milky Way. 30 are confirmed magnetars at the extreme high-field end. Pulsars have been catalogued since 1967, when Jocelyn Bell Burnell at Cambridge detected the first one, Pulsar B 1919+21. The timing of pulsar pulses has been measured with extraordinary precision. Anomalies in that timing, record glitches, spin-down irregularities, have been catalogued and attributed to mechanical rearrangements in the neutron star crust. The question of whether organized nuclear chemistry activity on a neutron star surface would produce a timing signature distinguishable from a crust glitch has not been formally posed in the published literature. The question has not been modeled. It has not been funded. It has not been asked. 1 billion neutron stars. 60 years of pulse records. We have assumed the pulsing is physics. The assumption has not been tested. We have not asked what we are hearing. Number 2. The Black Cloud. In 1957, Fred Hoyle published a science fiction novel called The Black Cloud. Hoyle was not primarily a novelist. He was one of the most important astrophysicists of the 20th century, co-author of the B-squared-FH paper of 1957, the foundational document of stellar nucleosynthesis theory, which established how every element heavier than hydrogen is forged inside stars. He was nominated for the Nobel Prize in Physics. In 1983, his collaborator William Fowler received the Nobel for the work they had done together. Hoyle did not. The circumstances were documented and debated in subsequent years. His exclusion was controversial among those familiar with the history of the discovery. The Black Cloud was a thought experiment published in narrative form. Its premise was that an interstellar gas cloud, drifting through the galaxy for billions of years, had organized its internal electromagnetic interactions into something capable of processing information, not biological life, not digital intelligence, something operating at a scale and in a substrate that had no precedent in any category human science had developed. The cloud metabolized energy through electromagnetic interactions. It used density gradients and magnetic field structures as a form of memory and processing substrate. It was not designed, it emerged. The real astrophysics supporting that premise has continued to develop since 1957. Interstellar molecular clouds contain amino acids, complex carbon chains, water, aromatic hydrocarbons, and precursor molecules for dozens of biologically relevant compounds. The compounds are real. The detection is spectroscopic, published in peer-reviewed journals, and not in dispute. What exists within those clouds beyond the detected chemistry is not fully characterized. Molecular clouds have internal structure, density gradients, filamentary organization, evolving chemistry, temperature differentials that drive energy flow through their bulk. Individual filaments within clouds have been observed to collapse and reform over timescales of millions of years. The internal evolution of a molecular cloud over 13.8 billion years has not been modeled for anything other than abiotic chemistry. They are not homogeneous. They are organized over scales no instrument has fully resolved. In 2020, astrophysicist Franco Vazza at the University of Bologna and neuroscientist Alberto Filetti at the University of Verona published a paper in Frontiers in Physics, comparing the structural complexity of the cosmic web, the large-scale filamentary network along which galaxies are distributed, with the structural complexity of the human neural network. Their methods were quantitative. They measured spectral density, clustering coefficients, and information capacity metrics using the same analytical framework applied to both systems. The results were numerically similar to a degree Vazza described in subsequent interviews as unexpected. The cosmic web's complexity on those specific metrics was comparable to the neural network of the human brain. The paper stated this as a structural observation. It drew no conclusions about awareness or function. Molecular clouds, operating at smaller scale than the cosmic web, but under the same physical principles of filamentary self-organization, have been accumulating internal structure since they first condensed from primordial gas. A cloud with a complex internal electromagnetic structure, energy gradients driving flow between regions, and 13.8 billion years of uninterrupted evolution in a substrate isolated from the disruptions that affect planetary life. The question that Hoyle's thought experiment asked is not whether this is biologically plausible. It is whether the distinction between biological and non-biological matters at sufficient scale and sufficient time. Hoyle's spectroscopic data on interstellar organic compounds was not refuted. The Cardiff Center for Astrobiology was defunded. The research line was not closed by finding a better answer. It was closed by withdrawing the resources to pursue it. The clouds are still there. The spectroscopic signatures are still accumulating. The question has not been answered. Number 3. Von Neumann probes. In 1948, John von Neumann, at the Institute for Advanced Study in Princeton, delivered a series of lectures later formalized as the theory of self-reproducing automata. The mathematics described a machine capable of manufacturing copies of itself from raw materials in its environment. Each copy does the same. The population doubles, then doubles again. The growth is exponential, limited only by the availability of raw materials and the travel time between them. In 1980, physicist Frank Tipler at Tulane University published an analysis in the Quarterly Journal of the Royal Astronomical Society applying von Neumann's mathematics to the galaxy. He began with one probe, launched from any star system at a fraction of the speed of light, 1%, 10%, whatever was technically achievable. The probe arrives at a neighboring star system. It uses local asteroidal material to build copies of itself. Those copies fan out to adjacent star systems. The process continues. Tipler calculated that a single self-replicating probe, starting from any point in the Milky Way, could fill the entire galaxy, every star system, every asteroid belt, every available material source, in approximately 10 million years. The Milky Way is 13.8 billion years old. 10 million years is less than 1% of that history. A civilization that developed the technology even a billion years ago would have saturated every reachable material reservoir in the galaxy long before Earth formed. Tipler's conclusion was that von Neumann probes are not here, therefore no advanced technological civilization has ever existed in the Milky Way. His argument rested on an assumption. He assumed that if the probes were present, they would be detectable. The assumption does not follow from the physics. A von Neumann probe built from asteroid material is chemically indistinguishable from asteroid material. If the probe's operational mode is passive, collecting data, processing information, waiting, it emits no electromagnetic signal that distinguishes it from inert rock. It has no thermal excess, detectable, above the background absorption, heating of any other object at the same orbital distance. It is, to every current instrument, a rock. The asteroid belt of our solar system contains approximately 1 million objects larger than 1 kilometer in diameter. Estimates of the total population, including smaller bodies, run to hundreds of millions. The physical composition of these objects has been analyzed for the tiny fraction that have been visited by spacecraft, and for a larger fraction by spectroscopic survey. The interior composition of any asteroid in the belt, its internal structure, the degree to which it represents unaltered primordial material versus something reworked, has been directly sampled for exactly a handful of objects in the history of the space program. The Vera Rubin Observatory, scheduled to begin science operations in 2025 and 2026, will produce the most comprehensive catalog of solar system small bodies ever assembled. It will detect tens of billions of objects. It will characterize them photometrically, measuring reflected light and inferring surface composition from albedo and color. It will not examine interior composition. It will not drill, sample, or subsurface scan any of them. The catalog will be the most complete survey of potential hiding places ever assembled. It will tell us nothing about what is inside any of them. If a von Neumann probe reached this solar system and replicated from local asteroidal material, the copies are in the current catalog. We have been imaging them as rocks for decades. We have not examined what they are on the inside. Number 4. Bracewell probes. In 1960, Ronald Bracewell at Stanford University published a paper in Nature titled Communications from Superior Galactic Communities. Bracewell was not proposing fiction. He was applying logic to the SETI question and identifying what he considered the most efficient strategy for an advanced civilization to make contact with emerging technological species across interstellar distances. His conclusion was not to transmit from a home world. It was to place an autonomous probe directly within the target star system, in stable orbit, programmed to wait for a local civilization to develop radio technology. When it detected radio emissions from the system, the signature of a technological civilization, it would respond locally, from within the system, eliminating the multi-year or multi-decade round-trip delay of star-to-star radio exchange. Bracewell published this in Nature in 1960. The SETI community acknowledged the paper. It then continued allocating essentially all available resources to scanning distant stars, rather than conducting any systematic search of our own solar system for a probe that might have been waiting there for millions of years. The long-delayed echo phenomenon provides the most specific anomaly. Beginning in 1928, Jorgen Hals documented radio signals returning from a fixed orbital position with delays between 3 and 15 seconds. The delays were inconsistent with any atmospheric or ionospheric reflection mechanism. The spatial geometry of the returns was consistent with an object in orbit. Duncan Lunan, writing in the journal Spaceflight in 1973, collected the delay records from the 1920s and 1930s and decoded the time delay pattern as a star map, identifying Epsilon Boötis as the likely origin system, a star roughly 203 light-years from Earth. Lunan later retracted his identification of Epsilon Boötis, while explicitly maintaining that the long-delayed echo anomaly itself was real and unexplained. No alternative mechanism has been published that accounts for the echo geometry. No program has been funded to reinvestigate it. In 2006, a NASA astrobiology panel recommended that the search for extraterrestrial intelligence include a systematic survey of the solar system, specifically targeting dynamically stable locations where a long-duration probe would most plausibly be placed. The Lagrange points, gravitationally stable positions in the Earth-Moon and Earth-Sun systems, were cited by name. L4 and L5 are located 60 degrees ahead and behind Earth in its orbit. Objects placed at those positions remain there without active station keeping for timescales of millions of years, making them optimal long-duration parking locations. The panel's recommendation was not funded. No systematic survey of those coordinates has been conducted. A probe coated in low-albedo material designed to absorb rather than reflect light at the approximate size of an automobile, positioned at L4 or L5 of the Earth-Moon system, is invisible to every current wide-field sky survey. Those surveys operate by detecting reflected sunlight. An object that does not reflect sunlight does not appear in the catalog. The point spread function of a dark, non-emitting object at L4 falls below detection thresholds for every instrument currently contributing to solar system survey programs. It would not appear in the Vera Rubin catalog. It would not appear in any catalog currently planned. Bracewell published the probe concept in Nature in 1960. The paper described exactly the object that would be invisible to current surveys. The long-delayed echoes of the 1920s are consistent with exactly the object he described. A NASA panel recommended searching for it in 2006. The recommendation was not funded. The Lagrange points have not been systematically searched. Number 5. Dark matter organisms. In 2014, Lisa Randall and Matthew Rees at Harvard University published a paper in Physical Review Letters proposing that a fraction of dark matter might interact with itself through forces analogous to electromagnetism, forming what they called a dark sector with its own photons, its own atoms, its own chemistry, none of it accessible to any instrument sensitive to ordinary electromagnetic radiation. The paper's primary focus was on the dark matter disk hypothesis, the proposal that self-interacting dark matter could collapse into a thin concentration along the galactic plane. But the theoretical framework established in the paper extended further than the specific hypothesis. If dark matter can have an analog of electromagnetism, it can, in principle, have an analog of chemistry. If chemistry, then in principle, biology. That implication Randall acknowledged in subsequent public lectures without elaboration. Dark matter constitutes approximately 27% of the universe's total mass energy content. Its existence is confirmed by at least 5 independent measurement methods: galaxy rotation curves, gravitational lensing of background sources, the pattern of the cosmic microwave background, large-scale structure surveys, and the behavior of galaxy clusters during collisions. It passes through ordinary matter without friction. For the entire 13.8 billion year history of the universe, dark matter has been threading through every star, every planet, every organism on Earth. Right now, it passes through your body at roughly 200 kilometers per second, in quantities measurable only gravitationally. The implication for biology follows directly from the physics. If dark matter has internal self-interaction sufficient to produce complex structure, those structures have been evolving for 13.8 billion years in a substrate invisible to any instrument ever built. Life on Earth has a history of roughly 3.8 billion years, and it has been reset repeatedly by extinction events that killed dominant lineages and forced complexity to rebuild from survivors. Dark matter structures, if complex, have had 13.8 billion years in a substrate that no asteroid impact, no gamma-ray burst, and no catastrophe in the ordinary matter sector could touch. Whatever has been running in that substrate has had more than 3 times the uninterrupted time available to Earth biology, in conditions of complete isolation from ordinary physical disruption. Here is the specific constraint that prevents this from appearing in the funded literature. Under the Randall-Rees model, dark matter interacts with ordinary matter only gravitationally. A dark organism of any complexity would be undetectable by any electromagnetic instrument ever built or currently under construction. It would pass through your instruments, through your body, through the full diameter of Earth, without resistance and without leaving any trace except gravitational. The gravitational effect of a single organism would be indistinguishable from background dark matter distribution. A population of organisms would be indistinguishable from a distribution of non-biological dark matter with the same spatial density. You cannot distinguish those cases with any tool that exists. In 2019, Randall was asked during a public lecture at the Royal Institution whether the dark sector framework was consistent with the possibility of dark life. Her answer was brief. "The physics does not prohibit it," she said. No one has modeled the conditions under which dark chemistry could generate the complexity required for biological systems. She said it was a question she found more productive to leave open. The recording is publicly available. No research institution has funded a study to develop the model she described as unpublished. The question cannot be written into a standard funding application without ending the conversation before it begins. The dark matter threading through your body right now cannot be examined for what it contains by any instrument that currently exists. Number 6. Magnetar entities. On December 27, 2004, the Magnetar SGR 1806-20 released more energy in 0.2 seconds than our Sun has radiated in the preceding 250,000 years. The burst was so intense it measurably ionized Earth's upper atmosphere from a distance of 50,000 light-years from the far side of the galaxy. The event saturated satellite instruments across multiple observatories simultaneously. Scientists at NASA's Marshall Space Flight Center described it afterward as the most powerful event ever recorded, originating outside our solar system. The object that produced it is approximately 12 miles in diameter. Its surface gravity is 200 billion times Earth's. Its magnetic field reaches 10 to the power of 12 Gauss, roughly a quadrillion times stronger than a refrigerator magnet, strong enough that if a magnetar were positioned where the moon orbits, it would erase every credit card on Earth from that distance. The surface material nuclear pasta was confirmed by observations of neutron star crusts published in 2018 in Nature Astronomy. It is matter compressed so densely that it no longer behaves as individual atoms. It behaves as continuous nuclear material. In 1979, physicist Freeman Dyson published a paper in Reviews of Modern Physics titled Time Without End. Dyson was not a fringe theorist. He was one of the principal architects of quantum field theory and had spent a career at the Institute for Advanced Study in Princeton. In that paper, Dyson examined what physical processes could sustain organized activity in the far future and concluded that the nuclear matter regime matter operating under nuclear forces rather than chemical forces permitted organized information processing structures of a kind that chemistry could not. The energy gradients available to a structure operating at the nuclear level are orders of magnitude beyond what any chemical process can access. The timescales over which those energy sources remain available are correspondingly vast. A magnetar provides what Dyson's framework describes. Energy gradients at the surface far exceed anything available in chemistry by orders of magnitude. The fuel supply, the decay of the magnetic field, and the gravitational energy of the object itself sustains output for millions of years without external input. The object is stable. It sits in a fixed position in space. It does not move in ways that would disrupt organized activity on or near its surface. The energy available to a nuclear chemistry system operating at the magnetar surface exceeds what the entire Sun delivers to Earth by many orders of magnitude, focused into a 12-mile object. Approximately 30 known magnetars exist in the Milky Way. Approximately 1 billion neutron stars exist in the Milky Way, of which magnetars are the extreme high field end. Pulsar timing is one of the most precisely measured phenomena in astrophysics. The rotation rates of neutron stars are used as natural clocks, accurate enough to test general relativity. Anomalies in this timing record, called glitches, are documented across the pulsar catalog. The standard explanation is internal rearrangement of the neutron star's crust, a mechanical slippage producing brief changes in rotation rate. This explanation fits most of the data. It has not been tested against the alternative that some timing variations reflect organized activity on or near the surface rather than purely passive physics. The question of whether organized nuclear chemistry activity on a magnetar surface would produce a timing signature distinguishable from a crust glitch has not been formally posed in the published literature. We have cataloged magnetar pulses for decades. The possibility that anything generates them has not been examined. Number 7. Interstellar comet colonies. Fred Hoyle was not a fringe scientist. He co-authored the B-squared FH paper of 1957, one of the foundational documents of modern astrophysics, laying out the complete theory of how heavy elements are synthesized inside stars. He is among the most important astronomers of the 20th century. Beginning in the 1970s, Hoyle and his collaborator Chandra Wickramasinghe at the University of Cardiff produced a body of spectroscopic work that the mainstream astronomical community found easier to defund than to refute. Their argument was specific. Interstellar dust clouds contain organic compounds. This was not in dispute. The question was what those compounds were. Hoyle and Wickramasinghe obtained infrared spectroscopic data from interstellar dust grains and found that the absorption profile, the characteristic signature of the grain composition, matched biological polymers, specifically cellulose and complex aromatic hydrocarbons, more closely than any inorganic compound model. No mineral compound, no simple organic molecule, no standard abiotic chemistry produced the absorption signature as well as dried biological material. The match was not approximate. It was quantitative. The Cardiff Center for Astrobiology, which Wickramasinghe led, produced decades of peer-reviewed work on this data. The institutional response was progressive defunding, relegation of papers to lower-tier journals, and a categorical unwillingness to engage the spectroscopic argument directly in the primary literature. No published paper successfully demonstrated that an inorganic compound model produced a better fit to the absorption data than dried biological material. The data was not refuted. The funding was eliminated. The Rosetta mission arrived at Comet 67P, Churyumov-Gerasimenko, in 2014. Its instruments detected glycine, an amino acid, as well as phosphorus, and a suite of complex organic molecules on the comet's surface and in its coma. The European Space Agency's press release described these as building blocks of life. The institutional narrative was that organics of this complexity are unsurprising on comets. What it did not address was the implication Hoyle and Wickramasinghe had spent 30 years pressing. If organics of this complexity exist in comets, and if comets travel between star systems, and if comet interiors provide liquid water during perihelion passes, while meters of ice shield the interior from ultraviolet radiation, then what travels inside them may not be chemistry. It may be biology. In 2017, an object designated Oumuamua passed through the inner solar system at a trajectory and speed, confirming it had originated outside our solar system, the first interstellar object ever confirmed in transit through this system. In 2019, Borisov followed, unmistakably interstellar and more structurally typical of comets. Both arrived from outside. Both passed through. Neither was examined up close. The comet interior is a viable biological habitat. Liquid water exists in the core during perihelion passes. The ice shell absorbs ultraviolet radiation. Internal temperatures during heating approach the liquid range. A microbial ecosystem could survive transit between stars over millions of years in deep freeze, revived during brief thermal windows as the comet swings near a star. Hoyle's original spectroscopic data was not refuted. Wickramasinghe continued publishing the analysis under progressively reduced institutional support. The interstellar transit of Oumuamua and Borisov confirmed that objects move freely between star systems on timescales the solar system receives regularly. The comets crossing between star systems right now have not been examined for what they carry. Number 8. Rogue planet leviathans. In 2011, Takahiro Sumi and colleagues published a gravitational microlensing survey in Nature. They had monitored 50 million stars over 2 years using the MOA-2 telescope in New Zealand, watching for the characteristic brightening that occurs when a massive object passes between Earth and a background star. The survey was designed to detect planets. What it found, in addition to bound planetary systems, was a population of massive objects producing microlensing events with no associated stellar host. The count of these free-floating objects, planets ejected from their solar systems, or possibly formed in isolation, was comparable to the total count of stars in the Milky Way. Hundreds of billions of rogue planets, dark, cold, radiating no starlight, visible to almost no current instrument. The thermal condition of a rogue planet depends on its interior, not its surface temperature. Rocky planets contain radioactive elements, uranium, thorium, potassium-40, that decay continuously, generating heat independent of any external star. The larger the planet, the more total radioactive material, the more sustained the heat output. For planets of sufficient mass, this internal heat is enough to maintain liquid water beneath an insulating ice shell for billions of years, without any contribution from stellar radiation. This is not speculative. It is the same mechanism that keeps Europa's subsurface ocean liquid today, despite Jupiter providing only trace thermal energy. Enceladus, Titan, Ganymede all maintain internal liquid environments through radiogenic heating and tidal dynamics. A rogue planet's subsurface ocean has a specific property Europa and Enceladus do not share. It is never disrupted from above. No asteroid impact penetrates miles of ice to reach the liquid layer. No ultraviolet radiation reaches the interior. No atmospheric catastrophe touches what lives at the thermal gradient between rock and ice. Evolution in a sealed ocean on a rogue planet proceeds in the dark, for billions of years, with no extinction-level interference from the surrounding universe. In 1999, David Stevenson at Caltech published a paper in Nature proposing that rogue planets with thick hydrogen atmospheres could retain sufficient warmth to maintain near-surface liquid water. The hydrogen acts as a greenhouse agent, trapping internal heat that would otherwise radiate into space. A hydrogen atmosphere rogue planet of Earth mass could sustain surface temperatures approaching the liquid water range without any stellar input. Stevenson's paper received attention from planetary scientists and was absorbed into the literature. No biosignature detection program was designed in response to it. No funded program currently targets rogue planets for biosignature search. No instrument is specifically designed to detect biological chemistry in the sealed interior of an unlit object moving through interstellar space. The Vera Rubin Observatory, coming online in 2026, will catalog rogue planets in unprecedented numbers through photometric transient detection. It will measure their brightness as they briefly occult background stars. It will not measure what is inside them. The numbers from Sumi et al. Put rogue planets at roughly equal count to stars. In a galaxy containing 200 to 400 billion stars, that is the same order of magnitude of cold, dark, sealed ocean environments, each potentially running biology for billions of years. None has been examined for what it contains. Number 9. Plasma lifeforms. In the mid-1950s, Soviet physicist Pyotr Kapitsa, who had received the Nobel Prize in Physics in 1978 for his foundational work in low-temperature physics, and who was among the most credentialed scientists of the 20th century, wrote a classified analysis of ball lightning that had been circulating in Soviet scientific circles. His argument was specific. Ball lightning was not a chemical combustion phenomenon. It was not plasma in the conventional sense. It was a self-organizing electromagnetic structure capable of sustained coherence in open air, responsive to external electromagnetic stimuli, propagating without any identifiable energy source that observation teams had been able to isolate. His summary conclusion was that the phenomenon was consistent with a form of electromagnetic life operating at timescales far faster than any biological process. Ball lightning has been documented on Earth. The conditions for plasma self-organization exist in space at scales beyond anything achievable on a planetary surface. In 2003, Erzilia Lozneanu and Mircea Sanduleviciu at Cuza University in Romania published a paper in Chaos, Solitons and Fractals, demonstrating that plasma spheroids created under controlled laboratory conditions exhibited spontaneous self-organization, self-replication, and response to environmental stimuli. The spheroids formed from plasma without external direction, divided to produce copies of themselves, and altered their structure in response to electrical changes in their environment. Lozneanu and Sanduleviciu proposed in the paper that these plasma cell structures represented a primordial form of life, capable of forming in conditions that predated any chemistry-based biology. The paper received citation in specialist plasma physics literature. It received essentially no coverage in mainstream science publications. Interstellar nebulae, stellar coronas, planetary magnetospheres, and the electromagnetic filaments threading galaxy clusters are environments in which charged particles interact under conditions of temperature, density, and field strength that no Earth-based laboratory can replicate. The self-organizing behaviors documented in these environments, persistent filamentary structures in nebulae, coherent current sheets in the solar corona, long-lived vortex structures in planetary magnetospheres, share a property that plasma physicists have noted in the literature with measured qualification. They organize as if directed. In 2007, Cassini's magnetometer and plasma wave science instrument recorded an electromagnetic vortex structure in Saturn's upper atmosphere, approximately 500 miles in diameter. The structure formed, persisted for 27 hours, moved against the local prevailing wind direction, meaning it moved without being carried by the medium it occupied, and then dissipated completely. The motion against the wind was not explained in the peer-reviewed summary of Cassini's atmospheric observations. The 27-hour persistence of a coherent electromagnetic structure without an identifiable energy source was listed as an open question in an appendix note and received no dedicated follow-up analysis. No follow-up observation targeting those atmospheric coordinates was conducted before Cassini's end-of-mission disposal in 2017. Cassini was not designed to search for plasma life. Its instruments were not deployed with that question in mind. What forms in a nebula spanning hundreds of light-years, where plasma self-organization operates under conditions exceeding the laboratory setting by orders of magnitude, has not been systematically surveyed. Laboratory plasma spheroids formed in a jar and replicated themselves. The question of what forms in a nebula 100 light-years across has not been formally asked. Number 10. The Black Knight Satellite. In December 1998, the crew of STS-88 photographed a dark object in polar orbit during the first assembly mission to the International Space Station. NASA's official explanation was thermal blanket debris, specifically a piece of insulation lost during an EVA. The photographs remained in the public record. Researchers examining them noted that the object's size, shape, and orbital characteristics did not match anything in the documented debris catalog for that mission. No further official analysis was published. The photographs from STS-88 were not the beginning. They were a confirmation of something that had been generating anomalous data for 7 decades. In 1928, Norwegian radio engineer Jørgen Hals observed a phenomenon that could not be explained by the physics of his time. Radio signals he transmitted were returning to his receiver in delayed echoes, arriving 3 to 15 seconds after the original transmission from a fixed orbital position above Earth. He reported the anomaly to physicist Carl Stormer. The phenomenon became known as long-delayed echoes. No mechanism in terrestrial or atmospheric physics accounted for them. Radio signals do not bounce back from empty space on a 3 to 15 second delay without a reflector. The orbital geometry of the delays pointed consistently toward a fixed object above Earth. Nothing built by any nation was in that orbital position in 1928. The first artificial satellite did not reach orbit until 1957. Nikola Tesla reported receiving structured radio signals from space in 1899 during experiments at his Colorado Springs laboratory. He described them as regular, patterned, and unlike anything generated by terrestrial sources. The laboratory notes referencing those signals were classified by the United States government following Tesla's death in 1943 and were not released in full for decades afterward. In 1973, astronomer Duncan Lunan published an analysis in the journal Spaceflight. He had collected the long-delayed echo records from the 1920s and 1930s and treated the time delay patterns as encoded data. His analysis produced what he interpreted as a star map, a schematic pointing to the star system of Epsilon Boötis, approximately 203 light-years from Earth. Lunan later retracted his identification of Epsilon Boötis as the specific origin point, citing methodology concerns. He did not retract the data underlying the analysis. The long-delayed echo phenomenon radio signals bouncing from a fixed orbital point with no identified reflector was never explained. The STS-88 object was in polar orbit. Polar orbit is significant because it is not a natural gravitational equilibrium for loose debris. Objects in polar orbit require active station keeping or extremely precise initial insertion, the kind of insertion that demands deliberate, controlled placement. Thermal blanket debris lost during an EVA does not achieve stable polar orbit. The mission telemetry relevant to the object's orbital parameters was not released. The object in the STS-88 photographs is approximately 30 feet across. Its surface appears to have structural geometry. The photographs are available in the public NASA archive. No space agency has launched a mission to examine the object at close range. No dedicated observational program has been allocated to track it through subsequent orbital cycles. The long-delayed echo data from the 1920s and 1930s has not been reanalyzed with modern signal processing techniques by any funded research body. All of it the neutron stars we have cataloged for 60 years without asking what lives on them. The rogue planets we count but never examine. The asteroids whose interiors no program has sampled. The dark matter threading through your body right now exists in the same universe as whatever was producing those radio reflections before we placed anything in orbit. We have been in the business of cataloging for a long time. We have not been in the business of asking. Whatever was in that orbital position has never been identified. The question has not been answered. It is still up there. If you want to see more videos like this, subscribe and hit the notification bell so you never miss what we cover next. Leave a like and drop a comment below telling us which of these you think is most likely to be real.